Hey, part two. Sorry, I only have 15 minutes to record each time because I'm using the free version of Screencast-O-Matic. But I'm sure you're quite happy to get a break in between my lecture. You're like, wow, can we only have 15 minutes of Mr. G every day? No. Anyway, I'm gonna go ahead and continue so I don't, talk too much and lose the time here. We're about halfway through this thing anyway. All right, I'm gonna minimize me. All right, back to preservation. Now we have freezing. Let me see a picture here. Let's see. There it is. All right, so freezing. I'm sure you understand what freezing is. Making it cold. You're freezing it, just in case you're confused. Anyway, bringing that temperature down to about negative 10 degrees Celsius, so it's actually below freezing. You don't want it right at that freezing level for water because, as we found out before when we were learning about solutions, putting stuff in water makes that freezing temperature change. So minus 10 degrees C is a good safe zone there. The reason we freeze things, as I'm sure you know, it makes it last longer, but the way it makes it last longer is because you're stopping that chemical change, or you're making the chemical change rate slower. It doesn't actually completely stop it. And it impedes the growth of microorganisms. Doesn't stop it entirely. It doesn't kill microorganisms, which is a good thing to remember because a lot of people seem to think, oh, sure, once it's frozen, it's good to go. No, that chicken that you froze, it didn't kill the microorganisms. You still need to make sure you cook it all the way because those organisms, those microbes, those bacteria that are on that food, a lot of times, a lot of them can still be alive, even through that freezing process. When you warm up that chicken, warm up that food, it warms up the bacteria as well. So make sure you still cook everything well. There's several different commercial freezing methods that we could go over. I'm going to only go over two. There used to be more on SmartPoint, but I was like, it doesn't matter those ones. Anyway, these are two of the most common ones. We've got blast freezing, which they use in a lot of packaged foods and meats and a lot of other things. There's a little video here. It's okay. It's good in that it describes the process on why we blast freeze. It doesn't really give like a video of it happening kind of thing. So the whole reason to blast freeze, it freezes very quickly with blasts of cold air, as the name implies. And the reason we want it to happen very quickly is because that leads to smaller ice crystals. As I'm sure, you may know, ice is less dense. Water expands when it freezes into ice, right? That's why you never want to put a super full bottle of water or a Coke or something like that into the freezer because you can burst that bottle, as I'm sure some of you have found out through experience. And the same thing happens to your food. So your fruits, your veggies, your meat, any of that, it all has water inside of it. And that's why the texture of food is never the same after it's been frozen. If you've used frozen veggies in your food you're cooking before, you know that they're much more limp and they don't have that crispness as fresh vegetable does. That's because every single one of their cells has been punctured by ragged ice crystals. The same thing goes for meat and whatnot. So blast freezing helps that process by freezing very quickly. It doesn't allow those big crystals to form quite as much. They make little crystals. So you don't have that puncturing of all the cell walls and cell membranes. So it helps the texture to be a bit better. Then another very commonly used one is fluidized bed freezing. So this one works a lot like those that dehydration method earlier, the tunnel dryer, where it's going on a conveyor belt through a tunnel. But instead of drying out the food, this one's freezing the food. So it goes into the tunnel, and they put this refrigerant, this liquid refrigerant, directly onto it, freezing it very, very nice and quickly. This is used on a lot of frozen fruits and vegetables. And in fact, this video here that I've linked to is actually probably one of my favorite ones I've linked to. It is a how it's made episode on making frozen fruit. It actually shows you the process really well. I think it's pretty cool. But we don't just have frozen food from the store, you can freeze your own foods as well. There are some tips for home freezing that you should follow so that we don't break some of those, I would say, rules, but so we have a better product that comes out of frozen stuff. One is to completely wrap that food, seal out the air. Air is your enemy when you are freezing, and the reason is because the freezer is a dry place. It's a desert, essentially. You have constantly the air being removed and recycled, being made cold. So because of that movement of air, it's going to wick away any moisture that's it comes in contact with. So if your food can contact the air, you're going to get what's called freezer burn. And essentially it's more like dehydration of your food, and it makes it very unappetizing. So having your food properly wrapped up, completely sealed, in a container, in a Ziploc, something like that, where no air can leave or escape or even come in contact with it, is going to be paramount. It's going to be very important. Portioning, also very important, because you might not want all of that food in one go. Let's say you made a big old pozole, and you've got a whole bunch left over. Instead of putting it all in one go, you want to put it in smaller containers, portion containers, so that you're like, okay, I want pozole today, just one for me. You take the little container out and you eat some of that pozole. But if you have it all in one big thing, either you reheat that whole entire container, or you pick it out with an ice pick and you try to chip out some of that soup. That's not going to work out so well. So portioning out to where you need it per meal is going to be very important. Labeling. You can already see here in the picture of the video that I'm linking to. It's a pretty good video, this one. I like this one too. You can see him doing the label. Having what is this that you're packaging and when did you put it in there is important to know. Okay, well, A, what is it? And B, how old is it? Is it still going to be good? Because again, stuff in the freezer lasts a whole lot longer, but it doesn't mean it lasts forever. If you get this mystery package, it's been in there for 2 years, might be like, maybe not. Anyway, and then high water content foods can be a problem as well, for that same reason I mentioned earlier about the ice crystals. So stuff that's really high in content, like tomatoes, you wouldn't freeze a tomato because it would just come out as mush and disgusting. Of course, if you're freezing soup, it's almost all water. That's a bit different. That soup's not going to change texture. So think about those when you are freezing at home. All right, canning. This is one of my favorite things to do. So hopefully, if we ever come back to school, we can do some canning. So canning is a way of preserving food by putting it into an airtight container, whether it's a metal can or a glass jar. We would be putting it in glass mason jars. And that jar is airtight, and you sanitize it, whatever's in there. Essentially, you boil it. You boil the jar to clean it out, to sanitize it, to kill the bacteria. You put the food in, you seal it again, you reboil that jar with the food inside of it, killing any bacteria inside of it again, and it also causes it to seal. And that seal makes it airtight, nothing goes in, nothing goes out. So food that's in a can, whether it be metal or glass, can last a really long time because there are no gases to get in to help that enzymatic breakdown happen, and there is no bacteria that can get in to break it down and make it dangerous that way either. There are a couple different kinds of canning, and that all depends on the pH of the food that you're going to put in that jar. If you have a low pH and acidic food, you can use a hot water bath, which is the kind we would have been doing at school. And that's great for fruits, for jams, jellies, pickles, preserves, because they have that acid content in them. The bacteria that can live in there are going to die at a lower temperature than, say, a non-acidic running one. For those that are non-acidic, you're going to have to use what's called pressure canning. And a pressure canner is essentially like a big pot that seals airtight. And because it's airtight, as it heats up, the pressure inside starts to build and build. And as that pressure builds, it causes it to heat even more because those molecules can't go anywhere. They just keep on rubbing on each other. And it gets a lot hotter than just a normal pot would. So that's going to kill those things like vegetables and meat, bacteria that grow in vegetables and meats, not acidic style. And that's important because, as I mentioned before, some bacteria like Clostridium botulinum, most dangerous one out there, happens to grow in improperly canned food. These kinds here. Let's see. Move on. I'm running out of time. All right. So pickles. I love making pickles. If you can make pickles at home, that'd be really cool. There's a couple different kinds of pickles. You've got the classic original type of pickle, which is a fermented pickle. So it uses microorganisms in the brine to preserve that food. There's a Magic School Bus episode that actually shows it. Anyway, then there's the fresh pack, which is the kind that we would do. We don't have to wait for it to ferment. Instead, you make the brine. You can just put them right in the refrigerator. That might be easier for you at home. Or you can can it right away, but essentially, you just put it in the brine, you put it in the flavor, and you let it sit for like a week or two just to absorb those flavors. You get some immediate pickles in. Alright, curing. Curing is a process that we use in a lot of meats, lunch meats, sausages, things like that. It involves adding salts, nitrates, sugars into the meat, which are going to help keep bacteria from growing, from being able to live on that meat. They give unique properties, unique flavors to that meat or other product. It's not just meats that we cure, but that's usually what we think of. And so it can last a very long time because of that. So I mentioned the salt, the sugar, the nitrates. You can see what they do here. But essentially, it's all about adding flavor and impeding the growth of bacteria and other microbes. A lot of cured foods, either you do something where you rub those curing products in, or you just put them in the case of sausage, you would include them in the meat mixture. A lot of our stuff nowadays, they do the liquid injection, inject it into that meat. This video here shows how they make chorizo, a Spanish chorizo. Spanish chorizo is different from Mexican chorizo because Mexican chorizos are typically fresh, while Spanish chorizos are cured. So they put in those curing ingredients, they leave them out to dry for a long time. So you get these meats that you don't need to refrigerate or anything because they've been cured. Smoking is another one of those curing type mechanisms where you've got some of those things in there. Smoke, you use a low temperature, and you're cooking. Essentially, you're cooking wood, and that smoke comes into the meat, and those things that make you choke when you're in smoke, those go into the meat. Just like you don't like to breathe that in, microbes don't like to breathe that in. So it helps to essentially preserve that meat, kill microorganisms in that meat, and gives it really good and unique flavors. Alright, so that's it. I'll be putting something assignment to go with this soon, maybe a couple different ones. Again, if you could do anything at home, that'd be really cool. Send me a picture of you doing one of these preservation methods, and maybe we'll get you some extra credit. Alright, I'll let you stop hearing me talk.